Hey, we are back at it with 11.3. This is Mr. Farrick on speaker here. The area of regular polygons, what we're learning today. What you're going to have to do in this section is identify what shape you have and then apply a formula that we're giving you to punch in the numbers wherever those components are and then solve for wherever that area will be. So we have squares. We have squares. Rectangles. And then this is a triangle. Right? Squares are for this formula here, side squared. Rectangles are base times height equals the area, and triangles are 1/2 times base times height. These we've probably seen before. We'll run into some other ones that we have not, but the shapes will be familiar to us. So in this first example over here, we have a square because all the sides are the same, right? 2.8. So what we're going to do is we're going to take the first equation up here and use that one. Side squared, so it's all the sides are 2.8 and it is squared. Now you just punch that into your calculator. Once you punch that into your calculator, you will get the area of the square. 2.8 squared, I got 7.84, and now you can use the label centimeters squared. The centimeter squared is because it's an area. Seen that, right? This would be a rectangle. There's a second one here. So I'm going to use this formula right here, base times height. So the base, 9.9. If you said 3, that's also fine. Doesn't really matter for this in particular. 9.9 times 3. There we go. That will get you, in your calculator, 29.7 meters squared. Right, notice we're just punching in the different letters for their values. Right, we said base was 9.9, so we punched in for the base. The height was 3, so we're going to say that, put that right into the formula. Same thing with triangle here. Different color. The base would be, so it's area equals 1/2 times base. Well, the base is 8 times the height, which is 9.6, right? So you could either multiply by half, multiply by 0.5, or divide by 2, whatever floats your boat. But all those being the same, once you punch in, or here, I'll write this too, 0.5 times 8 times 9.6, right? 1/2 is 0.5 in the calculator too. Punch all that in the calculator, you get 38.4 yards squared. There we go. That's a lot of what 11.3 is and a lot of what we've been doing before. Cool. Here are 3 more different kinds of shapes or polygons that you will run into. Rhombuses, kites. This will go to this formula. Trapezoids will go to the other one. D stands for diagonal. Right? And so we're going to use diagonal 1 times diagonal 2 and then cut it in half. You could divide by 2 as well, like I mentioned before. So let's do this first one. This first one, right, looks like a trapezoid, right? It looks very similar to that. So we're going to use this formula over here. 1/2 times the height times the quantity, base 1 plus base 2. So 1/2. So I can even write, if you really want to rewrite as 0.5, that's fine. That's why it's easier on the calculator. Times the height, looks like the height is 7. times the height, there you go, times the quantity, base 1 plus base 2. Well, this is base and this is a base. Does it matter which one's which base? Not really. Just make sure you add the 2 together there. So I'll just say 11 plus 3.2. Great. Make sure you use PEMDAS, P, parentheses. So I'm going to do the stuff in the parentheses first. 14.2 times 7 times 0.5. Right? Now you just multiply all these on your calculator. Right? 0.5 times 7 times 14.2. I got 63.9 inches squared. Right? Keep using inches squared or centimeters squared or whatever squared because it's an area. This next one looks like it is a kite, right? We have adjacent sides that are congruent. Adjacent side, that's congruent. Looks like we're going to use this formula, right? Because that's the rhombus or kite. That's going to be 1/2. So I'll rewrite this as 0.5 times diagonal 1. Now diagonal 1, make one or the other. Oop, there you go. That's the whole thing. So it's not 6. It'd be 6 plus 6, which is 12. Nice. Same thing over here. This is 2 plus 10 for the second diagonal. So 2 plus 10, oh, that's also 12. Now it's not always going to be the same, right? It's not going to always be the same diagonals. It could be 14 and 12 or 10 and 12 or something like that. So don't always assume that the diagonals are the same like this one. All right, looks like we have 144 times 0.5 or divided by 2. So that's going to be 72. If there's no units, then just put UN squared. Nice to be good with your labels. This one down here on your sheet, it has AC equals 8 and BD equals 12. It's not really labeled that well here, so I'm going to try to relabel it now. Oop, that's not that. I guess the trickiest of all this is making sure you punch it in correctly on your calculator. The calculator is not as smart as you might think. You are smarter than the calculator. Make sure you're putting things in the correct order in terms of PEMDAS, right? That's what's going to be your key to success. All right, so it's saying that this whole thing is 8 and this whole thing is 12. So it's going to be 0.5. Oh, sorry, we're using this one again, right? Because it's a rhombus. You know it's a rhombus because all these sides are congruent. So it's 0.5 times diagonal 1. Let's just say that's 8 times 12 is the other diagonal. You could do 12 times 8. It's fine. Punch it in the calculator. You get 48 units squared. Sweet. Area of an equilateral triangle. A little different than a normal triangle because all they give you is just the sides. They don't give you the height right here, right? So we can't use base times height divided by 2. So we're going to have to use this equation here, right? Which is just telling you to square the side, whatever the sides are, because they're all going to be the same. Multiply by square root of 3 and divide by 4. So area equals side squared. So it's 8 squared times rad 3 divided by 4. Cool. What you could do to simplify yourself here a little bit is say that's 64 because that's 8 times 8 or 8 squared. Then what I would do on the calculator is type in the top 64 times root 3 and then use that answer to divide by 4. Right? Sometimes you got to use one step at a time. So square root of 3 times 64 should have got you about 110.85. ish, but try to use that answer, and in the calculator, it'll say answer, hopefully, when you punch in the net, just divided by 4. Answer divided by 4, this will get you 27.713 inches squared. Now, in big ideas or anywhere else, you're probably going to be rounding to 2 decimal places over, so just 7.1 is fine, but good to be elaborate. Sweet. The last kind of thing that we're learning here, which you might tackle other times throughout the time we have here, and I'll break this up into 2 videos, is area of regular polygons. Polygons meaning pentagons, octagons, hexagons, things like that. And so we can find the area of those based off of certain criteria. So here's our formula that we're using like we have before. Now it gives you 2 formulas, but that equal sign in the middle means or. Really, they're the same equation, but they broke down the perimeter a little different. So take a look. 1/2 times A, the apothem, that's going to be a new word, times the perimeter. Okay, and this right here is the same thing, but that part I underlined is the perimeter. Number of sides times the side length. We'll see that in an example coming up. We'll use these steps in the other video, but for this one, for these 2 problems, we're just going to use the formula that they're given in the top left corner there. The apothem, let's explain that before we get going, is going to be from the center of your polygon and then drawn to one of the sides of the polygon, but it's going to do a few things. It's going to make a right angle. It's going to cut these 2 parts in half, making them the same, and it's going to also cut that central angle in half, making those 2 parts the same. Okay, that's what the apothem does. It does a lot of things. It applies more to the polygon than the circle. What do I mean by that? Is that this is an example of the radius. This is another example of the radius. Nope, if it's going to write. There we go. However, this, I'll use different color, is an example of the apothem. Right? It's only going to the polygon there, not the end of the circle. So that's important. Okay. I won't use yellow again because that you can't see. All right. Last 2 questions of the video here. Let's use the formula. Area equals 1/2. Same thing before. You can type 0.5. That's fine. Times the apothem. What's the apothem? It goes from the center to one of the sides, creates the right angle. So it looks like it's 14.5. Nice. Times the perimeter. Well, it looks like the perimeter is, with 12 is one of the sides. That's 12. That's 12. That's 12. That's 12. That's 12. That's 12. Nope, I can't really get there. Let's see. And this is 12. Right? So you could do 12 plus 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 12. Or you could just multiply by how many sides there are. 1, 2, 3, 4, 5, 6, 7, 8. Uh-oh. We're in trouble. Let's try this again. Right, there are 8 sides. This is what this, which is what this is talking about. Number of sides, we have 8 times the side lengths, that's 12. You could do 12 plus 12 plus 12 plus 12 plus 12, all those things to find the perimeter, or you could just multiply by 8. Okay, now we have enough information to solve the problem. Area equals all this stuff multiplied together. You could do 8 times 12 first if you really want to. It's all not going to matter at the end of the day, but it's good to have good practice. Do the stuff inside the parentheses first. The stuff inside the parentheses was 96. Right now, punch all that in. 0.5 times 14.5 times 96 equals, you should have got your area equals 696 units squared. Nice. All right, last one. You try it on your own, and then you go ahead and see if your answer is correct. I'm just going to kind of type in what you should have. The apothem, 1/2 times the apothem times, well, there's 5 sides because it's a pentagon, and each side is 7.5 long. 7.5 long. So then you're going to multiply. Great. Multiply all that stuff together. I got area equals 95.625 units squared. And that is what we have for this little lesson here.